In this video, we are going to learn about JavaScript classes. Classes are relatively a new concept in JavaScript and it was added recently in ES6 only. Before that, unlike other programming languages, JavaScript did not have a concept of classes. In fact, right now also, the ES6 implementation of classes is not a real implementation of classes as such compared to the other programming languages which have a proper implementation of classes. The ES6 classes is simply sort of a wrapper over function prototypes which are available, because that is how the JavaScript was built, and syntactic sugar short of syntax of classes has been created for JavaScript. But anyways, the way in which classes are created and the new syntax works, that is what we are going to learn in this video, and I think a couple of more videos, because it might not be completed in one video. Okay, so let's get started. Classes are basically a template for creating objects. If you remember earlier, then we had other ways also of creating objects, and specifically template way was constructor functions, right? And you can understand that classes are also like that only. In fact, classes are built on top of functions only. So internally, classes are essentially just special functions only, but with a new syntax. And as we mentioned before, the syntax of classes is newly introduced in ES6, the 2015 version of JavaScript. And we also discussed that the classes in JavaScript are not natively like when the language was designed, not from that time it is there. It is just recently added, and basically it's built on top of function prototypes. Prototypes we have not discussed in that detail, but a bit of that we are going to discuss here. That is fine. Like functions, class syntax has two forms. So like functions have function declaration and function expression, classes also have two syntax forms, which is called class declarations and class expressions, and they are similar to function declarations and function expressions. So let's see. If you remember that functions had two ways, right? When function declaration was there, then you can understand that we had something like function keyword, and then you can create some function like this, right? And expression was something like you create some variable with an expression function, something like this. So this was function expression. Okay, so in a similar fashion, like function keyword, we have a class keyword, and the declaration works like this: class, and then class name, and then curly braces, and inside that you write something called constructor, which is used to create the class object, which means that there is a way in which, like constructor functions, classes are invoked with a new keyword, and then it creates a new object. Okay, so we'll see that. So for example, we'll see a class keyword, and then you can create any you can have any name. So let's say square is the name of the function, and then you can have a constructor. In that constructor you can pass any variable. So let's say width, and that width we are going to assign to some variable inside class. So let's say that variable is width. We'll see that everything what we are mentioning here in detail soon, but let's get started. So what is happening is that when you do something like this, then this thing can be instantiated. So for example, let's say s is equal to new square. Okay, and let's say you pass 5. Right now, if you print s, then you'll see that a new object with width 5 is created. Okay, so you can see that there is a new object created, and in that object width attribute is there, and that attribute is assigned to 5. the same value which we are passing in the in this argument. Okay, whatever this argument is there, when this function is when new keyword is called, and with new keyword, when this class thing is called with this parents, then basically internally this constructor function is called, and then whatever arguments are passed here, they are passed from here, and then whatever things are assigned, those new variables, new you can say that properties are created in this object which is going to be created. So you can see that this width object, width property is being created in the newly created object. So you can see clearly here, right? And that's why you can see that s dot ss will be there, and then at s dot width will be 5. So all these things will be there. Okay. Next, like normal attributes, you can also have functions which are called methods in the context of classes. So and this can be like, for example, you can return this dot width square. Okay, so whatever is width, that square is the area, right? And then you can call s dot area, and then you will get the area of the square, which will be 5 into 5, 25. And you can see how it is working, right? From outside you can call s dot area. So so you can see that s on s object internally, this thing this function is available, which can be called, and in turn it returns the property, whatever the width property is there, it's a square it returns, and that's why it gets 25. Okay, so yeah, that is fine. We saw this. Apart from that, the actual name of the function, so let's say this from object, let's say you just have the object, right? You just have the object, nothing else. From this object, how can you know that what is the name of the actual class? So actually you can see that yeah, sorry, so not from object, you cannot do that, but on, so this thing is sort of a static property available on the name of the function, name of the class itself. So name of the function dot that thing. Okay, so that is fine. Now you might be thinking that, yeah, we already know that this is square dot name, then what is the purpose? It gives again square, but later we'll see that in function expressions, that sometimes you can assign the function class expression in some other variable, but still the name will be same only, whatever the first time it was created. So anyways, we'll come back to that soon, but this is the basic idea of class declaration. One important thing is there, that unlike function declaration, class declarations are not hoisted. So we saw earlier that if we had functions, then even if we declare function, let's say after we use, then also it was available, right? It was hoisted to the top. That was the hoisting, right? But here you'll see that when I do this, then I'll get error, which means that this thing is not getting hoisted. Okay, so functions, obviously arrow functions were not hoisted, but normal with function keyword, whatever the functions were created, those were hoisted. But unlike those function declarations, class declarations are not hoisted. Okay, that is fine. And later we'll see that class expressions are there, but then function expressions also did not get hoisted, right? So like function expression, class expressions are also not hoisted, but that is not a surprise, because obviously nothing is hoisted in expressions. But the only thing you have to remember is that for declaration, the function declaration used to be hoisted, but class declaration is still not hoisted, which means that for class related thing, and nothing is hoisted at all. Okay, in function only you have to just remember that declaration is hoisted, but expression is not hoisted. Okay, that is fine. Let's get start. Let's start using some example of simulating the sort of classes using using constructor functions. So you'll see that just close correlation. So just now we saw that, yeah, something like this we just now created, right? Something like this we just now created. So s dot width, s dot area, something like this we have created. Now how this stands in front of constructor functions. So we earlier saw that we had something like this. So this dot width is equal to width, and this dot area is equal to function area, right? And this also, and when we did s equal to new square, then this also had a similar effect. Okay, this also created an object, s object with width attribute set and an area function attached to it, and if you call that, then you get the whatever the width square. Okay, so that is so now you can understand that this is like sort of a different syntax, which is a class sort of syntax, which is supported with respect to, actually there are other things like inheritance or subclassing, those sort of things. So for that matter, classes are like so that you can relate it with some other programming languages. That's why this new feature was this new syntax was incorporated. But otherwise, for normal basic things, you could do very well those things with normal functions also. Okay, however, there is one more way in which you can do, that is using prototype. So rather than defining width and area both here, what you can do is that you can do you can just declare, like, let's say only width, and then you can write something like this: capital square, the name of the function itself, dot prototype dot area is equal to, and then you write something like this. What this does is that whenever using new keyword, you create some object, then on that object this area thing is this area function is attached. Okay, so now you can understand that when you are using new keyword, so when you are simply using new keyword, then prototype is the one which is getting attached. So just as a rule of thumb, whatever you are doing with function name dot prototype dot something, that thing is attached when using that function. You use that function as a constructor function, and then you use new keyword, and then what object is created, in that those things are attached. Okay, so now I am using new keyword, and then this s will have all the things which are defined on prototype. So area, so s will have area, right? If you don't call new keyword, if you don't call this function with new keyword, then s will not have area attached to it. Okay, so that's what I was trying to mention. New keyword is necessary for the prototype chain to get attached. Okay, so that will be like brief introduction for prototype. Prototype and prototypal chain is like a larger concept which we might study in detail later, but for now it should be sufficient. Okay, so just I was trying to say that this is also one of the ways in which the similar thing which we are doing here can be achieved using normal functions and prototypes. Okay, now let's come back to class expressions. So like function expression, function is equal some variable is equal to function that thing will. Similarly, you can do something like class expressions where you are assigning a particular class to a variable. Okay, if you do something like this and then you write a square dot name, then you will get a square. Okay, so the first time whenever some name is attached, then that class will have a particular name attribute set to that variable. But you mind that this is for the first time. So let's say you do this, and you can see that here after class the name is not given. It's like similar to functions, right? You can understand that when you are creating a function, so let's say function, independent function, when you are creating, that is fine. So you are doing like this, right? But let's say you are assigning it to some function, some expression. So like a function expression, then const, let's say p is equal to something like this. Then here the name is not necessary, though you can give name, but that is not necessary, right? In a similar fashion here, after class thing, this since it is assigned to a name, already being bound to a name, so here the name of the class is not necessary, but you can write that also. But in this case, if you write the name here, then the hoisting is not happening in expressions at all, that is fine, right? But here if we write name here, then we will see that actually the name attribute, which is static attribute, which is bound to what is static attribute, will come that come later, but we'll see that for now I'll just mention that static attributes like name dot name is simply the thing which is attached, which is available directly on the class rather than instance. You don't need to create instance to access that. You can simply take the class name and dot that attribute you can access. So right now if you see, then square dot name, if this variable dot name you see, then actually the name is coming to be my square, and that is because this is the name which was first attached, and that's why the name will remain this only. Okay, earlier we saw that when this thing was not there, then whatever the variable here was there, that is going to be name, but this is not the case here. Okay, and one more thing we have to remember is that the body of the class is executed in strict mode, which means that earlier we saw that yeah, we generally when we use ES6 modules, then we saw that it was using strict mode. Similarly, when we are using classes, then classes also by default use the body, whatever, whenever you are using anywhere inside classes, the code, that whole code is using strict mode. Okay, and you can test that here. So for example, let's say const is strict is equal to, and then we know this way of testing, right? So this function and once we do this, then we can print this is strict to see that actually what is the, if it is true then it is strict mode, otherwise it is not strict mode. And you can see that it is strict true, which means that the body of the, and anywhere like here or constructor and anywhere you write, everywhere inside the body of any class, the mode is by default that is executed in strict mode. Okay, so that will be a brief introduction to classes. We'll go through some more syntactic structures in the second video. For example, constructors and all these method, what are attributes, what are methods. These are things which we have not gone into much detail. So that we are going to do in the next one.